right, so this video is going to be about inverses specific to logs and exponentials. This could help anytime you're trying to do inverses, but this is to generally help my Algebra 2B class. We already learned inverses. I already gave you notes on it. We already did practice on it, and there was some problems in Eureka that you did. But I think that you're going to need some more practice specifically with logs and exponentials. So what I have is I have a worksheet for you. At the top it says Algebra 2B inverses, logs, and exponentials. And I'm going to do several of the problems through this sheet, running through my steps for inverses. So as a reminder for inverses, the first thing that you do, normally it has an f of x. You replace that with y. We don't want the f of x in there. The y is what we need. Now, we talked about, and I had a video about it, and we talked about it in class a little bit, the idea that when you take the x and the y and you flip them, that's one of the processes to get you an inverse, because it's going to reflect across the line and all that sort of stuff. But what you're literally going to do is take the x and the y in the equation and change their places. Then you're going to solve for the y using opposite operations. So everything about inverses is opposite operations. And then, this is a good step to do, but I know not everybody's going to do it, and that's okay. When you get to the end, it's a nice idea to replace y with f inverse of x. So, sorry, is he... sorry, I have a child that's trying to get into my video right now. So it should be Thursday in class. Hopefully, if you need this, you're watching it and you're working on the worksheet. Or you could watch this anytime about inverses. But I am hoping to be back Friday. I got scolded by the doctor. So let's start with the very first problem. The very first problem on the worksheet says y equals log base 4 of x to the 5th. And what I want you to notice is I actually have this worksheet written so that all of them are y's. That's why I put the little star here, because for these equations, the y is already here. We don't need to replace the f of x. All right, so now I'm going to move to my second step, which is to take the x and the y and literally exchange their locations. So now I have x equals log base 4 of y to the 5th. Okay, now generally you're looking for anything algebraic that you would need to move. So if there was addition happening, if there was subtraction happening, if there was multiplication happening, if there was division happening, we would want to deal with that. At this point, though, the only thing that's happening is this log. So the opposite of a log is an exponential. So what I'm going to do is I'm going to introduce a base that matches on both sides in order to start to get this log gone and this y alone. So I'm going to do a log 4, right? It was log base 4, so now I have 4 to the x equals 4 to the log base 4. The 4 to the log base 4 reduces, and I'm left with y to the 5th. And now my last step is to get rid of this 5th power. And, excuse me, sir, and anytime I have a power, like a squared or a cubed or a 4th or a 5th or a 6th or whatever, I get rid of it by taking the 5th root, or the whatever root it is. These two should be the same, and what they'll do is they'll cancel each other, and I do that on both sides. Here they're going to reduce, so then I'm left with the y equals the 5th root, oh, that was a terrible 5, the 5th root of 4 to the x, and then if you want, hold on a second, if you can't handle being quiet for my video, for my students, then you need to leave.
Could we just drink water?
Then stop talking. Sorry about that. Okay. So then what I would do to just indicate to everyone that I'd reached the end, the y was alone, I did opposite operations, which was exponential, and the opposite of power was radical. I would just say f inverse of x equals the 5th root of 4 to the x power. Now, if you leave it like this, I would completely take it. You would be completely correct. This is just like a nice math way to say, hey, I reached the end of the problem, and I know that I got the opposite of the original. Here it's a little bit weird because we don't have f of x to start, but this just says the opposite operation of x, the regular f of x. Okay, so that's the first problem. If you look at the worksheet, the majority of the problems are going to kind of follow that pattern, but I am going to do another one. I think I'll probably do maybe problem number 4. And then if you flip the page over, you'll see some that are written in exponential, and we'll do a couple of exponentials together as well. All right, but I want to do another log that's got a little bit more to it, just so that when you see it, you can go, okay, I'm sort of following the steps. And I'll be back to help with it, obviously. I'm just not right at this moment. All right, so you can pause the video, get all of this if you need. I'm going to go ahead and erase it. The steps are the same, no matter what the problem is. So if we were talking about an Algebra 1 inverse problem, like a line, it would be the same steps. If we were talking about the opposite of a quadratic, it'd be the same steps. These steps for inverses are constant. They're not going to change. What changes are the problems. So I think problem number 4 looks a little strange, and I could see people doing some very strange math to this. So I'm going to go ahead and I'm going to try this one and see how it goes. I haven't done this problem before, so hopefully it's not a super hot mess. First step is to replace f of x with y. We already have y, so now I'm going to exchange the x and the y. Okay, now I'm going to get the y alone. Now this is really bizarre. This looks like this looks like this says log base y of 2 minus 9, and it's very tempting to subtract these two. But think about this as kind of all together logged, and then this extra minus 9 hanging around. So the idea is I want to move that minus 9, and you already have right math instincts. You haven't practiced log and exponential enough. So what we should do is move that minus 9 by adding it. That now gives us x plus 9 equals log base y of 2. Okay, now here's where it's going to get a little weird. We are going to go ahead and we are going to introduce our base to get rid of the pieces, and it's going to give us kind of a weird fractional bit, and we're going to have to do some backwards work, so let's see how this goes. All right, I'm going to introduce y now as my base. I get y to the x plus 9 equals y to the log base y of 2. These two will cancel. Now, here is where we're going to run into some trouble. And actually, thinking about it, I actually feel like we might be better off stopping here. Because even though the y isn't completely alone, if we try to take y on both sides, we're just going to end up having to log again to remove it. So I think log base y of 2 is going to be as simplified as we can get in this particular problem. So it's not a very good answer because it's very frustrating to leave this in terms of a log base y. But because the unknown is the base, sorry, that's my cat, go away. Because the unknown is my base, I think it's just best to leave this problem like this. I think that there are some more advanced steps we could take, but I think this is about as far as we want to go with it. So notice, mathematically, because this was a base, and I don't think I did any more like that. That one's pretty gross. Number 9 will be similar, so don't be afraid to leave number 9 in its particular format. But generally, if this is a number, you would go through more of a step, more of a process. For here, we just move the 9. Now we're going to leave the log base y in 2. All right. Now I want to do an exponential. So if you flip over your paper, or I don't know if they copied it on the second page or whatever, let's do an exponential problem. Maybe let's look at 11, which is the first of the exponentials. Says y equals 6 to the x over 3. The x and the y, sorry, it's chaos in my room right now. I've got my husband who's helping me film this, my children who I don't know why they won't go away and go play, the dog and the cat. It's like mass hysteria in the room. Okay. We already have f of x replaced with y. Now we're going to exchange the x and the y. Now I want to get the y alone. So I'm going to get rid of the fraction right away because this is dividing by 3. We get rid of dividing by 3 by multiplying both sides by 3. So now I'll get 3x equals 6 to the y. And now this is slightly different. Because this is an exponential, we're going to introduce a log of the same base. So I'm going to introduce log base 6 of 3x equal to log base 6 of 6 to the y. And what will happen is the log base 6 of 6 should cancel, and we should be left with y equals log base 6 of 3x. Okay, you're going to need to practice. What you'll see is a lot of the exponentials will follow the same sort of a pattern. So I might do one more of those, maybe problem number 18, and because there's a lot of them in similar style to 18, and then you will have some time to work, hopefully. Okay, so this is problem 11. Notice I did opposite operations. This was divide, so I multiplied. This was exponential, so I logged with the same base. I got to the point then where y was alone, which gave me my inverse. All right. One more and then this video is done. Number 18 says y equals 6 to the x over 3. It already, Andrew, can I have my water, please? Thank you. All right, why don't you two go upstairs and play?
I'm just going to watch.
All right, so the y is already there. I'm going to exchange the x and the y. Now, I want to deal with this 3 here, but I can't yet.
Go away and play somewhere else.
Sorry, the dog just licked the children. All right, boys. Boys, when you make too much noise, then they can't hear me. All they're going to hear is you guys.
Go upstairs. Go.
Okay. Yes. Just go away. All right. I want to deal with getting rid of this 3, but I can't yet until I get rid of it as an exponent. So right away, before I do a step, I'm going to go ahead and introduce the log. This has a base 6, so I'm going to log base 6 both sides. What will happen now is these log base 6 of 6 will reduce. I'll be left with log base 6 of x equals y over 3. And now it's actually sort of the opposite direction that the last one took, or opposite formula, but it's because this one is up here in the exponent and the last one wasn't. How do we get rid of divide by 3? We multiply both sides by 3. So I'm going to get 3 times log base 6 of x equals y. And that will be my inverse. Okay? You've already seen inverses, whether you were completely paying attention or not, so you should already have notes on inverses. These inverses are all going to be log and exponential, and they're generally going to follow the patterns of what I just did in this video. The steps are going to remain the same, all right? You will have, the next test is going to be pretty much graphing using the calculator, describing transformations, which you saw on Tuesday, and then solving inverses. The last time I wrote this test, about 36 points were solving inverses, and I had some students who ended up not passing the test because they didn't practice their inverses. So make sure you practice your inverses. Okay, I should be back Friday if all goes according to my plans. And then we will have a weekend, and then we will have a very short week next week. So have a great day.